The tech industry remains fixated on language models, treating the intelligence layer as the ultimate prize. In reality, raw compute has already become a commodity, a proprietary, highly accurate, and causally linked internal record of business activity creates the only defensible moat for a modern enterprise. Metastone Properties, a multifamily operator in South Dakota, faces a common hurdle. Their operational reality is fractured across AppFolio for management, ClickUp for tasks, and Retell for AI voice reception. Deploying an autonomous agent directly onto these siloed legacy APIs is a recipe for failure. Without a unified memory of what has happened across the portfolio, the agent lacks the necessary context to act. Autonomous operations require a single, queryable ground truth, where physical reality is extracted from these tools and unified into a coherent record. The Exavion Skywalk pipeline executes this extraction. A Cloudflare worker at the edge fetches data from 6 upstream systems and writes it into a D1 database. This storage layer centers on the events table, a 19,000-row unified activity log that serves as the system's memory. A standard activity log provides insufficient structure for an autonomous agent. A simple list of timestamps and strings fails to provide the causal links an AI needs to reason effectively. An AI-ready schema relies on 4 uncompromising structural invariants to turn a raw log into a reliable memory bank. These 4 rules prevent the agent's context window from filling with duplicated, disjointed, or chronologically false noise. This is the SQL create table structure for the events table, illustrating how the database enforces these invariants through specific column types. The first invariant is temporal truth. The schema deliberately separates the occurred at timestamp from the recorded at timestamp. Naive logging systems usually stamp every row with the current time during ingestion. If an API failure causes data to arrive 3 days late, the log incorrectly records the event as happening today. Decoupling these timestamps preserves historical accuracy. The system knows exactly when an event took place, regardless of when the data pipeline actually processed it. The second invariant, strict item potency, is enforced for the dedupe key column and its constraint. The compute layer executes idempotent upserts. This allows sync jobs to be safely rerun any time, as the database rejects any attempt to write the same event twice. Separating time and fingerprinting rows creates a chronologically perfect memory bank. This technical baseline is required for an AI to trust the data it is reading. The third invariant is physical entity resolution. Abstract digital events must map to tangible, real-world assets. Through the occupancy ID column, 95% of the events in the log link directly to a specific tenant and unit. Prospect data, like tour bookings or rental applications, is correctly left unlinked. This isolates the core rent roll logic from the noise of the leasing funnel. The final invariant is native causality, enforced by a self-referencing foreign key in the cause event ID column. Take Felicia's stove repair. Finishing it generates a woe.completed event for work order 3149. This completion rigidly links backward to the specific woe.created event that started the repair. The system currently maps 3,000 linked pairs across maintenance, communications, and tasks. These causal chains allow an AI to navigate the business timeline logically. Instead of seeing a sequence of random actions, the agent calculates why those actions occurred. A pristine schema is only useful if it survives the chaotic ingestion pipeline. The most significant operational bottleneck in this architecture stems from the strict rate limits enforced by legacy software vendors. Every day at 14 UTC, a scheduled cron job attempts a massive burst sync, firing requests at the Skywalk API simultaneously. This spike reliably exceeds the allowed threshold, resulting in an HTTP 429 too many requests error. When these requests fail, rental endpoints and financial snapshots drop offline. Critical data like tenant balances can remain stale for over a week. While a human dashboard can tolerate a temporary delay, an autonomous agent's context window cannot. When the sync advances past these blocked requests, the resulting gaps act as irreversible brain damage for the agent's historical memory. Solving this requires abandoning burst requests in favor of a paced, tiered synchronization strategy. By utilizing exponential backoff and retry logic, the system prioritizes absolute historical completeness over the need for real-time freshness. Pipeline logic must ensure that rate limits never silently delete reality, or the most elegant edge schema becomes useless. This topology map shows the Xovian system footprint, including all 49 tables from core entities to financial snapshots. The build order begins by extracting raw reality from siloed legacy software. Step 2 is constructing a unified data layer, anchored by a schema-rigid events table. Step 3 involves writing explicit automation rules, logic that reacts to causal chains to trigger immediate alerts for Tor no-shows or bounced payments. Only after these layers are secure can you deploy the autonomous operations agent. Deploying the agent layer before cementing the data layer guarantees operational hallucinations. Without a trusted ground truth, the AI has no baseline for its decisions. Reliable AI agents require a diet of data strictly bounded by idempotency, causality, and temporal truth. Competitive advantage in AI comes from engineering proprietary data moats that serve as digital physics for the business. This approach prioritizes schema rigidity over the commoditized race to fine-tune larger models.